This is Algebra Lesson 8.4, Square Roots. So a perfect square is when you take a number and multiply it by itself. We know lots of perfect squares, hopefully 1 times 1, 2 times 2, 3 times 3, 4 times 4, which we'll fill out in just a second. A square root is the opposite of that. A square root is when you have a number that when you take the root of it, it would result in something times something to get that value. So a perfect square would be when you take the square root of that number and you get a whole number. So our perfect squares, at least the first 10 that we're going to talk about, are 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, 5 times 5, which is 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, and 10 times 10, 100. We could keep going, 121, 144, 169, etc. But if you need more, you can keep a list going. We're going to try to use these perfect squares to help us estimate the answers of our square roots. So, example A, estimate the answer, then calculate to check the answer. The square root of 28. If I look at my list of perfect squares, I'm going to find which set of perfect squares 28 falls immediately between. So 28 falls immediately between 36 and 25. So I know the square root of 28 should be somewhere between 5 and 6. It's going to be 5 point something. And I'm going to just say, well, is it closer to 5 or is it closer to 6? Is 28 closer to 25 or closer to 36? I think it's closer to 25, but it's not super close, so maybe go 5.2 or 5.3. So this is our estimate. Now I'm going to use my calculator to check if that's the right answer. I will go the square root of 28, and I get 5.3 if I were going to round that better. So that was pretty close. Letter B says the square root of 78. 78 is between 64 and 81, so I know the answer is going to be 8 point something. 78 is closer to 81 than it is to 64, so I'm going to go closer to 9 than to 8. How about 8.8? And again, we're just doing an estimate and then checking the decimal value on the calculator. And 8.8 is very good. The square root of 200. Now I stopped my list at 100. So I would need to keep going 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15, and so on. But I've gotten further than I need now because it's going to be between one of these two. So this is 11, 12, 13, 14. So it's going to be close to 14, probably a little higher than 14. Let's try 14.2, maybe 14.1. We'll just see what happens. .1. So this is a way that you can estimate your roots when you don't have a calculator handy. If you know your squares, find the square that it's between and estimate it that way. Now getting exact answers is a little more complicated, and that's going to require us to look into some factors. So if I have the value 20, what I need to do is break this down into my perfect squares. So I know 20 is the same as 4 times 5. 4 is a perfect square. So if I have a perfect square, I can take the root of that value and pull it out. And I think the easiest way to do that is keep breaking it down until you get a pair of numbers, and then that pair of numbers is what you're going to pull out of the radical. the radical stays, and then whatever doesn't get pulled out stays under the radical. So when I got a pair of 2's, I pulled it out of my square root symbol, a single 2 for the pair, and then the 5 stays underneath. So the way that I'm going to check my answer on my calculator is I'm going to type in my original expression and the expression that I simplified it and see if they have the same decimal answer. So I have the square root of 20, and that is 4.47, and then I have 2 square root 5, and that is the same decimal answer. Letter B, I have to break up 252. This is a bigger number, and I'm not exactly sure of my factors right now. I'm going to just try and see what I can find. So 252, let's try 16. Again, I'm looking for perfect squares. So 16, that is no good because I need to get a whole number for this to work out. So 252, one of my perfect squares is 4. Well, that worked out. So I can do 4 and 63. So I'm going to break this up into 4 and 63. And right away, I know 4 breaks into 2 and 2, so I'll be able to pull a 2 out of my radical. 63, that's not a prime number, so I can keep going on that one. And I know 63, I know my 9's is a 9. 9 is one of my perfect squares, so I can pull out a 7 and a 9 from 63. And 9 is one of my perfect squares, which I know will give me a 3 and a 3. So what happens is I can pull a 2 out of this, and I can pull a 3 out of this. Pull a 2 out and pull a 3 out. 7 stays underneath. But I don't want to leave it in this format. I'm going to multiply back together my 2 and my 3, and my 7 stays underneath. So my answer is 6 root 7. And I am going to again put that in the calculator to check my answer. Oh, I didn't write that one down, did I? 4.47. So I'm going to go back there really quick. Okay, so 252. I think I'm going to, so I can see, there we go. Root 252 and 6 root 7. Same decimal answer, so I have the right answer. Last one, I'm looking for perfect squares that I can pull out of 280. 280 divided by 25. It ends in a 0. It might be by 5. Nope, no good. 280 divided by 4 or 16. Let's try 16 first. Nope. 280 divided by 4. 4 and 70. So I'll know we'll be able to pull out a 2 then. I'm going to keep going. 70 I know is 7 and 10. And 10 I know is 2 and 5. So I just kept breaking it up, and now I'm going to look for my pairs. I can pull out a 2, but it doesn't look like I can pull out anything else. 2 is prime, 5 is prime, 7 is prime. So I'm going to pull the 2 out, and the 2 and the 5 and the 7 remain. So 2 root 70 is as reduced as this one is going to get. I just did 2 times 5 times 7. Brought that right back to the 70. Let's check our decimals. Root 280. And then root 2 root 7. 70. There we go, 16.7. Okay, so the last example is the same, but we're going to add some variables in there too. So this first one actually isn't any different because I'm going to take my 125 and I'm going to divide that. I'm pretty sure 125 divides by 5. I'm sorry, 25. And I get 25 and 5. And I went with 25 because being a perfect square, I know I'll get a pair of 5s out of that. So I have 5 from the pair, and then the 5 still underneath that didn't have a match. I don't have the check your answer on this one because I was introducing the variables, and you can't really type those in your calculator. You could check just the numerical portion, but you don't have to check, you can't really check the variable portion. So this was root 125, and then I have 5 root 5. checks. 512. 512 divides by, let's try 16. That worked out. So I have 16 and 32. I know 16 is 4 and 4, so I'll be able to pull out a 4. 32. Let's try 8. Okay, I can pull out an 8 and a 4. 4 is going to give me a 2 and a 2 that I can pull out. 8 is 2 and 4. 4 is going to give me another 2 and a 2 that I can pull out. So I'm going to pull out a 2, and a 4, and I have a 2 left behind. That is the same as what we were doing on example B. Now looking at the letter, we're going to actually do that the same way. M splits into 3 M's. If we talked about M times M times M, back to our exponents. So I'm going to pull out a pair, meaning I'm going to pull out an M right here, and I have 1 left over to stay inside. So if I simplify all that, I need 2 times 2, which is 4 times 4, which is 16 on the outside, M, and everything else is as it is. And the last one, 16, right away, that's a 4 and a 4 that I can pull out. U4 is U, 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 so I got a pair of U's here and a pair of U's here. V3 is V, 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 so I have a pair of V's right here. I pull out a 4, I pull out a U, I pull out a second U. Oops, I didn't want to go that far yet. So I got to do my V still. I pull out a V, and then underneath a V remains. Combining all this, the 4 stays 4. 2 U's we're going to represent as U squared, V root V. So that was kind of a long one. Hopefully you stuck with me. Good luck on the exercises, and let me know if you have any questions.